This is an example of a geometric proof. We're going to start with some basic information here, the segment addition postulates. If B is between A and C, just like we see in our diagram down here, then we can say that AB plus BC is equal to the entire segment AC. So this part of the segment plus this part of the segment gives you the entire segment, is what that is. It's like an addition problem. So this is your segment addition postulate. You can add the two segments together that share the common B to get the larger one, meaning that B has to be between A and C. We can compare that to the angle addition postulate. The angle addition postulate states that if D is between, or D is in the interior of triangle or angle ABC, D's in the middle of it, then notice here we can say that this angle right here, I'm going to trace it, this angle added to this angle makes the very large angle. So what does that mean? Well, the measure of angle ABD plus the measure of angle DBC will equal the entire angle, the large angle, the measure of angle ABC. And that's your angle addition postulate. Now you can use that information to solve a problem like what you see right here. If you look at this one here, we have been given a particular proof to complete. So we're given that AC is equal to BD. Those two segments we're told are going to be equal. So you always start a proof with your given statement. AC equals BD. What's the reason? Well, it's given. And then we got to look. See, if I'm looking at this and I know that AC and BD are the same length, that's what the given tells me. I notice that there's an overlapping region here saying, they've got BC in common. If they've got BC in common, let's just see what happens if I subtract BC out of both of them. If I subtract BC out of both of them, I'm left with AB and CD. That's kind of what I need for my proof statement, so I wonder if there's a relationship. So if I'm trying to subtract, then maybe I should be looking at the segment addition postulate, which would be the inverse operation. So I could say what I just learned about the segment addition postulate is that AB plus BC gives me the entire length here, AC. And that's what this piece here says, AC equals AB plus BC. I can also look at the second half here. BC plus CD is giving me the large length here, BD. So there it is, BD equals the BC plus CD. So this right here represents the segment addition postulate. Now, why would I want to do something like that? Well, again, remember that this overlaps. I wondered if I could subtract it or get rid of this part eventually so that all I'm left with are these two statements. Well, to do that, you're going to have to start combining the information that you have. For example, we've got AC and BD. They're the exact same value. So notice right here, I have AC. They match, which means I could replace this AC with what it matches with, the BD. That can go right into there. So that's going to be my next step. BD is going to substitute in, replace AC, but I'm going to rewrite the rest of the statement. AB plus BC. So all I did was, since AC and BD are the same, I substituted in here. Now that is the substitution property of equality. Why would I do that? Well, now if you look very carefully at this statement and this statement, what do they have in common? Well, they both are equal to BD. They're both equal to it. So I can say that this piece here, which represents BD, can go in place of the BD. I can substitute that whole thing in. Or vice versa. I could have put the AB plus BC into that one. But regardless, if I put this into here, what I've got is this expression is equal to this expression. These two expressions are equal because they equaled the same thing. What is that? Again, we did the substitution property of equality. Now, look very carefully, because if you notice, there's that BC, the overlapping region that they both have. And if I went ahead and just subtracted it from both sides, they would both cancel. So there it goes and cancels, and leaving me with the two segments I wanted, AB and CD. That is what I needed to do to prove. Notice that my proof statement is the last thing I have. It's exactly what I wanted to prove, but I still have to justify what did I do here. Well, I subtracted, so I used the subtraction property of equality.